Now, suppose that we've discovered some imaginary root of a polynomial. And that's something that we might have because there are certain methods that will let us discover these imaginary roots. Suppose we've found one. How can we use it? Well, if we've guessed a real root of a polynomial, we know how to use it. Let's try using this imaginary root the same way. And if this were real, I would just divide by the corresponding factor and see what I get. So we'll set up synthetic division. 1 minus I is a perfectly good number. And then the coefficients of our polynomial are 1, -4, 3, 2, and -6. So we drop down the 1. 1 times 1 minus I, that's no problem. That's 1 minus I. -4 plus 1 minus I, well, that'll be -3 minus I. And now we need to multiply -3 minus I times 1 minus I. Okay, well, that'll be -3. Minus 3 times minus I is plus 3. Minus I times 1. Minus 3 times minus I is plus 3I. Minus I times 1 is minus I. Minus I times minus I is plus I squared, which is the same as -1. So we have -4 plus 2I. -4 plus 2I. Add the 3, well, that's -1 plus 2I. And now we've got to multiply again. So -1 plus 2I times 1 minus I. That's -1 times 1 is -1. -1 times -I is plus I. 2I times 1 is plus 2I. 2I times -I is minus 2I squared. That's going to be, let's see, well, minus 2I squared is the same as plus 2. So we'll have -1 plus 2 is 1. I plus 2I is 3I. So we've got 1 plus 3I. Add those up. And we've got 3 plus 3I. Multiply one more time. 3 plus 3I. 1 minus I. 3 times 1 is 3. 3 times -I is minus 3I. 3I times 1 is plus 3I. 3I times -I is minus 3I squared. That's the same as plus 3. Oh, so that gives me 6. That really was a root. So that gives me factors x minus 1 minus I and x to the third plus -3 minus I x squared plus -1 plus 2I x plus 3 plus 3I. I don't like that. I don't want to deal with that factor. I don't want to do all that complex number arithmetic. There's got to be an easier way. And in fact, there is. We can handle imaginary roots exactly the same way that we handle real roots, but we shouldn't, because it makes our life more difficult than it has to be. If we know one complex root, we know that its conjugate is also a root, and we can put those together to get an irreducible quadratic factor. So quadratic, degree 2, irreducible, no real factors, but all of the coefficients then will be real numbers. There are two ways to do this. We can think in terms of the factors. So x minus 1 minus I is a factor. X minus 1 plus I is also a factor. First terms, we've got x squared. Outer terms, minus 1 plus I x. Inner terms, minus 1 minus I x, plus last terms, 1 minus I times 1 plus I. So we've got an x squared minus 1 plus I plus 1 minus I x plus, multiplying these we get 1 squared plus 1 squared. So we have x squared minus 2x plus 2. So that's one method. No problem if you're comfortable working with the complex numbers this way. Another way to do this is to think of roots. X equals 1 plus or minus I are roots. And now we're going to run our completing the square process backwards. So our goal is to get 0 on one side. And the way we're going to do that is to subtract 1 from both sides, square both sides. So x minus 1 squared is x squared minus 2x plus 1, plus or minus I squared is negative 1. And we'll add 1 to both sides. This is the polynomial that has those roots. Either way, we get this irreducible quadratic factor. With that in mind, let's try that again. If we have this polynomial, and 1 minus I is one of its roots, then x squared minus 2x plus 2 is one of its factors. We can divide by that. Unfortunately, we can no longer use synthetic division. We have to use regular polynomial long division for something that looks like that. So x to the 4th minus 4x to the 3rd plus 3x squared plus 2x minus 6. X squared goes into x to the 4th, x squared times. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x to the 3rd. X squared times 2 is 2x squared. And then we subtract. Negative 4x to the 3rd minus negative 2x to the 3rd is negative 2x to the 3rd. 3x squared minus 2x squared is 1x squared. Bring down the 2x. Divide. Negative 2x to the 3rd divided by x squared is negative 2x. Negative 2x times x squared is negative 2x to the third. Negative 2x times negative 2x is positive 4x squared. Negative 2x times positive 2 is negative 4x. And now we subtract. 1 minus 4 is negative 3x squared. 2 minus negative 4, we have positive 6x. Bring down the last term, it's negative 6. Negative 3x squared divided by x squared is a negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2x is positive 6x. Negative 3 times positive 2 is negative 6. And we get no remainder. We should get no remainder because we already knew the thing we were dividing by was a factor. Okay, now what? Well, this is already factored. That's how we got it. That was x minus 1 minus I times x minus 1 plus I. Now we need to factor this new quadratic. Well, let's see if the old techniques work. 3 terms, quadratic, leading coefficient is 1. We can use the shortcut. We need 2 numbers that multiply to negative 3, add up to negative 2. Negative 3 and positive 1 will do it. So our last 2 factors are x minus 3 and x plus 1. There we go. We have fully factored this polynomial using that given complex root as kind of a key. We now know everything that we're going to know about factoring. In the next video, we're going to see the whole process from start to finish.